All right, guys, we're going to begin with lesson 5.3 today. And what we're starting to do is look at how we can prove two triangles are congruent. And there's several different ways we can do it. But today we're just going to focus on two of these properties, which are side, 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 and side angle side properties. Okay. First of all, if you're just going to prove two triangles congruent, what you normally have to do is you got to prove that all six pairs of corresponding parts are congruent, which means you got to prove that all three angles are the same measure and you got to prove that all three side lengths are the same. All right. So what these properties that we're going to look at today do is they allow us to kind of take a shortcut, so we don't have to prove all six corresponding parts congruent. Rather than that, we can just prove three of the right combination of parts are congruent. And so there's five different ways we can do this via a shortcut. All right. So the five different properties we could use are the side, side, side property, which basically says we got to prove that all three sides of one triangle are the exact same lengths of all three sides of another triangle. And if I can prove all three sides are congruent in the two triangles, then that means all the other parts have to be congruent as well, which means all the angles have to be congruent. Okay, so if we can prove all three sides are congruent, that's enough to say the two triangles are congruent, which would then mean that the interior angles would all match up as well. Okay, the second shortcut is what we call side angle side. And what we're going to do here is we're going to prove two sides of one triangle are congruent to two sides of another. And if we can show the included angle is the same measure as the other included angle in the second triangle, that's enough to say the two triangles are congruent. All right. So again, it's the three parts that work here. Is that it's got to be two sides and the included angle. And if I can just prove that much, okay, that's enough to say the two triangles are congruent and all the other parts are going to be congruent as well. Okay, those are the two we're going to focus on today. I thought I'd just give you the whole list though, and we'll start working off of that. So the next one is angle side angle, which I know you can assume that if we can prove that two angles in one triangle are the same two angles in a second triangle, and the included side between those angles is congruent to the included side of the second triangle, then that's enough to say that those two triangles then have to be congruent. All right, so that's enough. Just proving the two angles and the included side and two triangles are congruent is enough to say that the two triangles are congruent. Okay, angle side is the fourth one that we could use. And here, just as it says, if I can prove two angles and the non-included side in two different triangles are congruent, that means the two triangles have to be congruent. And then the last one we have is called hypotenuse leg. And this deals with right triangles. And basically, if you have a right triangle, a pair of right triangles, you already know you have an angle that's the same measure. This one says if we can prove that the hypotenuse and the leg in those triangles are congruent to the hypotenuse and leg in a second triangle, then those two triangles are congruent. So again, this is my full list right here. Side, 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 side angle, angle, side angle, angle, side, hypotenuse, leg. All right, now, which one of these do you choose to prove two triangles congruent? Well, it depends upon the information you're given. All right, so today we're going to focus on these two, side, 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 and side angle, side. So all the information given to us is going to allow us to make one of these two as my conclusion. It doesn't matter which one you use. Okay, as long as you can use one of them, we're just trying to prove two triangles congruent. So it all depends on the information given. Okay, the first type of question you're going to have today, or I'm sorry, let me take a step back. Let's look at side, side, side a little bit more in detail. And again, side, side, side congruent says that if three sides of one triangle are congruent to three sides of another, that's enough for the triangles to be congruent. All right. So here you can see from the drawing that AB and ED are the same length. By the little markings here, you can see that BC and EF are the same length, and you can see AC and FD are the same length. They're giving us that in the drawing. Okay, because they give us that much information, that allows us to say then these two triangles have to be congruent. All right, now what that means is not only, obviously the three sides are the same, but now we know that angle C and angle F have to be the same measure. Okay, we know We know angle B and angle, what would it be? E have to be the same. And we know A and D would have to be the same angle. The side allow us to say the angles are congruent. And then once they're congruent, that means the other parts match up as well, which are the angles in this case. Okay, the second one we're going to look at today is side angle side. All right. And this one you just have to be careful with because it's got to be what we call the included angle to use this one. So if you look at what's given here, we're told that AB and ED are congruent. We can see that BC and EF are congruent. All right, so I got two sets of sides shown to be congruent. If I want to use side angle side, I have to have the included angle between the sides. Now, what that means is basically the angle that's made by the two sides that are congruent. So you can see that angle B is made up of AB and BC, which are the sides that are congruent, and angle E is made up of FE and ED. So it's got to be the included angle. So if we get this much to be true, that's enough for us to say the triangles have to be congruent. Okay. So in this case, I can now say I know this triangle is congruent to this triangle. They're going to be identical to each other, which means I now know that AC and FD have to be the same. I know angle A is going to be the same as angle D, and C is going to be the same as F, just because I now know the triangles are congruent. All right, now we'll look at a couple of the problem types that we're going to be dealing with. And there's really only two types. One is where they do the proof for us, okay, and we got to fill in the missing parts of the statement and the reasons. And the second one is going to be when we have to actually do it ourselves, create the whole proof. Okay, so one big part of this, one key part of this is that when you're doing one of these proofs, I think it's extremely important that you make a drawing and make a plan for how you're going to do it. All right. So in this case, here's my givens, or here's the information. I want to prove that triangle ABC and triangle DEC, I want to prove those two are congruent. All right. So remember the congruent statement. Okay. We talked about this a little the other day. So I know A and E, or excuse me, A and D, those two angles should correspond. B and E's angles should correspond. And C and C, and we're going to look at that in a second, they should correspond. All right. So what we're going to do is let's take this drawing off to the side here and let's put in what we know. And then obviously, how are we going to try to prove it? Okay. So what are we given? We're given that BC and EC are the same length. So I'm just going to mark that in the drawing. I'm told that AC and DC are the same length. I'm going to mark that in the drawing. Okay. Now that's all we're given. So we have to figure out, what else can I get out of this drawing? Because I'm not given any more information. What else can I get out of the drawing so that I can either prove these two triangles congruent by side, or side angle side? All right. Well, we're not given any information about DE or BA. All right. So my other choice would be to look right here. You can see that these two are vertical angles. Okay. So since they're vertical angles, they're congruent. So just from the drawing, I'm going to be able to take that fact out. Okay. Now what you see is I've got side angle side, side angle side. So that's going to be how we do our proof. All right. So when you go to do these problems, it's going to be important that you make a drawing and that you put the facts that are given to you in the drawing, and then figure out what do I need to get to the conclusion and how am I going to use the drawing to do that. So you need to write this stuff out. All right, let's finish this up here. BC is congruent to what? And that was a given. Well, right up here, BC is congruent to EC. That was a given. AC is congruent to DC. Well, that was also a given. Now, here's the part that we just made a conclusion of in that drawing. ACB, so this angle, ACB, right, is congruent to, I put DCE. Now, you could have put ECD. That's the same thing. And the reason is because they're vertical angles. And then finally, we know that these two triangles are congruent by the side angle side congruence property. Okay, so you guys, you've done these before. You'll have to choose these from a list that's provided, and you're going to have to fill these in. All right, so that's the first one. That's the first type you're going to see. Similar question. So again, we're asked to prove that triangle RST, this triangle is congruent to RUT, and we're going to do that Um, we're given ST is congruent to UT, RS is congruent to RU. Now, again, the first thing I'm doing is I'm making this drawing on my own, and I'm going to put in what I know. Okay, what are we given? Well, we're given that ST and UT are the same length. We're given RS and RU are the same length. Okay, so there's what I'm given. Now, what else can I pull out of the drawing? Well, if you notice, the two triangles are sharing this side, RT, right? So that means this side is shared and it's congruent to itself. So there's my third side. So if you look at triangle, RST, right? And then RUT, they both share side RT, which is congruent to itself. So these two triangles are congruent by side, side, side. All right, let's go down here and fill it in. Again, make the drawing so you can see all this. ST is congruent to UT, that's a given, STUT. RS is congruent to RU, that was a given. RT is congruent to RT. Remember that conclusion we said? That's by reflexive property. Any segment's congruent to itself. That's reflexive. And then the triangles would then be congruent because I've showed all three sides are congruent, side, side, side. Okay? Now, the second type of question you're going to get tonight is where you have to write the whole proof yourself. It's basically the same as the first two we did, except they're not going to lead you through the process. You're going to have to do it on your own. So if you look up here, we're going to prove triangle ABC is congruent to triangle EDC. We're given BC congruent to DC, AC congruent to EC. Okay, now again, take the drawing off to the side, put in what you know. BC is congruent to CD. Those two sides are the same length. AC is congruent to EC. Those two sides are the same length. Now we're either using side, side, side or side angle side. Okay, that's all we're working on right now. So I don't have any information about the length of AB or DE, and I don't have any way to figure that out. But what I do see in the drawing is that these two angles are vertical, therefore they're congruent. So there's the three pieces I needed. There's my side, my angle, my side. Side, angle, side. Now I'm going to be able to prove the triangle's congruent. Okay? So start writing in your proof. Okay? BC is congruent to DC, given. AC is congruent to EC, given. Okay? So there's my side and my side. Now I got to enter in the angle. Angle ACB congruent to DCE by the vertical angles property. There's my side, angle, side is in the proof. So now I can say the triangles are congruent by side, angle, side property. Okay. So it's pretty much the same proof. Now you have to write it. All right. One last one. All right. So here's the given shape. Okay. We're trying to prove that ABC, this triangle, and ADC, this triangle on this side, are congruent. Okay, here's my given information, what we're trying to prove. So again, take your drawing off to the side, write in what you know. I know BC is congruent to DC, and they tell us that AB is congruent to AD. Now again, we're either using side, 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 or side, angle, side. You're not given any information about angles, nor is there any way I can show any information about angles, right? But what I do know is that these two triangles share this CA side, and CA is congruent to itself. Okay, so I'm going to be able to prove the two triangles congruent by side, side, side. Okay, but you got to draw it out. Okay, so step one, BC congruent to DC is a given. Step two, or statement two, AB is congruent to AD, that's a given. So there's two of my sides. Okay, oops. CA is congruent to CA. There's my third side. That's my reflexive property. So here are my three sides that I've proven congruent. So now I can say the triangles have to be congruent, and that should be a triangle deal right there by side, side, side. Okay. All right. So those are what you're going to be working on tonight. Those are the styles of questions. If you need to go back through and look at them, go back through and look at them. Okay. But the homework tonight is just like those types of questions. So I will let you have at it.